Hi, in the last period I provided a question for giving reason the fact that if action and reaction forces are the two forces with the same magnitude but opposite in direction, why don't they cancel each other and leave no net force on an object? The reason is simple. This is because these two forces can't cancel each other because they act on two different objects. Action and reaction forces cannot cancel each other and leave no net force on an object. The reason is because they act on two different bodies. Because they act on two different bodies. Now, suppose a force is applied on a wall. If this is a wall, when a force F as an action force applied on a wall, then a reaction offered by the wall is negative F. A reaction offered by the wall is negative F. This is a reaction. This is a reaction. So these two forces can't cancel each other because they act on two different objects. For instance, when we fire a bullet or we hit the wall, when we hit the wall, the force is applied on the wall by an object, and the reaction force offered by the wall has the same magnitude, but the direction is different, and so they can't cancel each other. Okay, today we want to learn about an impulse of the force. Impulse of the force. Impulse of the force. Before we proceed with the applications of Newton's second law of motion, now what is an impulse of the force? By definition, impulse of the force is defined as the product of magnitude of the force and the time taken by this force to act on an object. The product of magnitude of the force and the time taken by this force to act on an object is called impulse of the force. So it is the product of magnitude of the product of magnitude of applied force and the time taken by this force to act on an object. Now recall from Newton's second law of motion, which is the applied force F is given by the rate of change of linear momentum. The rate of change of linear momentum. Okay, when we multiply by time t both sides, we get now applied force F times time t equals to mv minus mu, then times t out of t, time t we cancel out, and the equation becomes force F times time t equals to mv minus mu. Now, where F times t represents an impulse of the force, and its SI unit, it is Newton, its SI unit is Newton second, and S Newton second. Also, Newton second can be expressed in terms of linear momentum SI units, because we can define impulse of the force as the change in linear momentum. Impulse of the force can be defined also as the change in linear momentum. Since linear momentum is expressed in kilogram meter per second. Also, Newton second can be expressed in terms of kilogram meter per second. Newton second, the same as kilogram meter per second. Okay, we can ask ourselves that why a goalkeeper draws his hands backwards while interested to stop a fast moving ball. Why? The reason is simple. A goalkeeper draws his hands backwards while interested to stop a fast moving ball because as he draws his hands backwards, he increases the time of impact. As a result, he reduces the impulsive force in order to avoid injury. The goalkeeper draws his hands backwards when interested to stop a fast moving ball in order to increase the time of impact so as to reduce the impulsive force and so as to avoid injury. In the next lesson, we are going to start learning about applications of Newton's second law of motion, which including apparent weight, how we can obtain apparent weight on an object inside an elevator while moving either downward or upward, or while moving uniformly with acceleration due to gravity. Also, we shall consider the motion of connected objects, the motion of connected bodies on a flat surface, and motion of connected bodies down the plane, down an inclined plane, and motion of bodies or masses connected by a string past through place. Don't miss the next lesson, PM Classroom. Thank you.